Lesson 1, Basic Programming Terms. All right, let's kick things off by getting familiar with some basic programming terms. Even if you're already a bit familiar with them, it's always good to do a quick review. Before we dive in, make sure you're comfortable with the following topics. Modify and run your first verse program. Now that you're all set up in verse with UEFN, it's time to make sure you have the basics down. This lesson starts with the fundamentals, and having a solid grasp on these terms will make the rest of the lessons flow much smoother. What's a program? Think of a program as a set of instructions for the computer. It's like telling the computer what to do, how to take in information, input, and how to send out information, output. It's basically giving the computer a job to do. What's verse? Verse is a programming language for video games and simulations. It's designed to work perfectly with game-specific needs, so it's great for creating gameplay mechanics. Verse programs are here to solve problems, but be warned, computers are super literal. They do exactly what you tell them, no more, no less. Think of it like a contract with a genie. Be specific, or you'll get something totally unexpected. Compiling. We write programs so humans can understand them. But the computer can't just read our code directly. We need to use something called a compiler, which translates our code into something the computer can actually understand. Algorithms. An algorithm is just a fancy term for a set of instructions that solves a problem or gets a task done. For example, making your cat's dinner might look like this. 1. Grab the can of cat food. 2. Get the cat's bowl. 3. Open the can and spoon the food into the bowl. 4. Put the bowl down where the cat can reach it. And if you miss a step, like forgetting the spoon, you'll end up with an unhappy cat. If you repeat this process every day, that's called a loop. Just like feeding your cat twice a day, it keeps going until you stop it. In Fortnite Creative, when you're building game mechanics with devices, you're basically setting up algorithms. It's all about figuring out how the player interacts with the game and which devices will make the gameplay work or mess it up. Testing an algorithm. Now let's take an algorithm for a spin in real life. Try making a cup of tea or coffee using a written algorithm. Follow the steps exactly. If the tea tastes great, congrats, you nailed it. If not, you might need to debug the steps and try again until it's perfect. Source code versus machine code. Source code is what we, the humans, write. It's the original human-readable version of the program. But the computer can't read that, so we need to compile it into machine code, the language the computer understands. Execution. When a computer actually runs your program, that's called executing the code. If it doesn't run the way you want, there could be errors in your code. Errors in code. Errors show up in two main ways. 1. Compiler errors. This happens when the code won't compile because there's a problem with the syntax. Every programming language has rules for how the code should be written, called syntax. 2. Bugs. Bugs are when your code compiles fine, but the program still doesn't do what you expect. It's like your program does the thing, but not the right thing. Compiler errors. The most common cause of compiler errors is incorrect syntax. If you don't follow the syntax rules, the compiler just won't work. It's like writing a sentence in English that doesn't make sense. You wouldn't expect anyone to understand it. In verse, the code is case sensitive. That means if you don't get the capitalization right or you miss a space, the computer will throw an error. For example, verse print, hello world. This works. But if you forget a closing parenthesis, verse print, hello world, this throws an error. Bugs are trickier. These are issues that pop up when your program is running, but it's not doing what you want it to do. It's like the syntax is fine, but the meaning behind the code is off. For example, in verse if mice caught tat 0, print win, else print lose. But if you accidentally change the condition like this, if mice caught 1, print win, else print lose. Now, if only one mouse is caught, the player will never win, even though the program runs perfectly fine. It's a bug in the logic. Summary. To wrap things up, a program tells the computer how to take input and output information. Computers are very literal. Make sure you tell them exactly what to do. Programs need to be compiled from human code to machine code. Algorithms are instructions that solve problems. Source code is human readable. Machine code is computer readable. Syntax is the set of rules for writing code. Compiler errors prevent a program from compiling. Bugs happen when the code compiles but doesn't work as expected. Practice time! This simple algorithm shows how a player wins when catching a mouse. 1. Mouse spawns near the player. 2. Player chases the mouse. 3. Player catches the mouse. Your turn. Now let's expand this algorithm. The player starts with 5 gold coins, receives a coin for every mouse caught, loses a coin for every mouse that gets away. Write out the steps of this updated algorithm in as much detail as possible. There is no wrong way to do this. It's just an exercise to get you thinking about how to break a problem into steps. Solution. Here's an example solution. 1. The game starts. 2. Player begins with 5 gold coins. 3. A mouse spawns near the player. 4. Player chases the mouse. 5. If the player catches the mouse, the player gains 1 gold coin. 6. If the mouse gets away, the player loses 1 gold coin. 7. Repeat steps 3 to 6 until the game ends. Feel free to modify and improve this algorithm. Experimenting with different steps is a great way to get comfortable with writing algorithms. And that's a wrap for Lesson 1. Stay tuned for more, and happy coding. Let me know if you'd like further adjustments.